This is Superheroes Group and we are starting our project. So our project is level control, and here is my group team, Fu and Izzati, and this is our fourth member. So this is Iwi Wong and Fu and Izzati and me. And this is the equipments we got. We got the ultrasonic sensor, and we have got the microcontroller, and then the jumping wires and connecting wire. So we will do the coding now and we will come back to you. So basically it will look something like that. So this is the Arduino, this is the ultrasonic sensor, and this is the water, and here is our results. Stop. Okay. So we have measured the flow rate of the inlet, and now we will try to measure the flow rate of the exit. So this is the end of day one, and we have almost completed the model. So we just need to slightly edit it, but we have completed like around 30% of the process, the whole process, and that's it for today.
Day 2.
So this is kind of our last design for the process, and here we can see our results. So it is kind of good results, but not the final one yet, because we haven't got the steady state yet, but we are working on it.
A few moments later.
See, I think the problem with this design is that the sensor is not at the middle. So basically the waves, they hit the edges and they kind of intersect with each other. So it is not giving steady state results. So we need to kind of adjust it to the middle and try to set the offset for it. So we have almost reached the steady state with a little bit of error, and here you can see that it is steady. So right now what we will do is that we will increase the flow rate and see how much volume changes with time. So now you will see it rising. And you will see our results here. Should be decreasing. Yeah, it is decreasing with a slight of error, and that's how we get our data.
The next day.
So yesterday when we did our video about the tank, we forgot to measure the magnitude of the difference in the inlet. So basically we have to repeat the whole process again. So just now we are trying to rebuild the system, and we'll come back to you with the results. And this is our trial 1. See, it is not always so much fun to measure the flow rate while you don't have a proper system. because it always changes and it always gives you different results. So we are trying to take the average of all the experiment data we have got, and we will try to see what we get.
Hold on to me, 'cause I'm a little unsteady, a little unsteady.
So this is our fourth or fifth attempt to reach a steady state, or to make our system work, and it does work, but we don't always reach to the expected results. 1, 2, 3. No. Okay, stop.
Later.
Okay, this is attempt 6 to reach our perfection of the system, and the time we have spent is, like, you will see it somewhere up there, and we will keep trying.
6.5 hours later.
So just now we will try to see the steady state flow, and we'll show you the time lapse of the steady state. So it is pretty steady state, and we have measured the flow rate of it, and now we will try to change the magnitude of the inlet so that we get our transfer function. Okay, this is our code for the Arduino, and here, as you can see, we are telling it to take 50 data a second, and we will go ahead and upload it. That's it. You can see it is uploaded already, and we will go here to check the monitor. And these are our results. So just now we are at the steady state, and then we will clear the output, then we will increase the inlet of the flow rate. So just now we are clearing the output, so this is our steady state. Then you can go ahead and change it. So just now we are increasing the flow rate of the inlet, and we will see the system increasing. And we should see our results in here. So it is actually decreasing in the distance, and that means that our reactor or our tank is overflooding. So finally we are done with getting the data, and you can see here our graph. That is the steady state, then it is decreasing in the height, and the other one, this is the increment of the volume. So it's a pretty good result, and we will try to do the regression now and get the transfer function.
2,000 years later.
Historical moment of our work. We have got the transfer function. Izzati,
Tati. Hi.
you want to say something?
Finally. Yeah.
Okay, let's show. So this is our graph, and it fits perfectly, and these are our results, the theta and tau and k and m. So now we will write the transfer function, and we will do the tuning, and we are done. This is day 4, and we have done the first part of extra marks. We will show you the complete results of our whole process. So this is the steady state time, which is the time that took us to measure the flow rate of the steady state, and this is the final time, which is the time that took us to measure the flow rate after the increment. So this is our steady state flow, and this is the final flow rate. This is the final flow rate, and that concludes the increment of this value. And this is our area, and this is our steady state. This is our steady state height. So here we could measure the steady state. So as you can see, it is steady at the beginning, then it starts to increase in the volume, and it starts to decrease in the height. So back to our regression, we did the same method as we did in the lab, and we got our graph here. You can see it perfectly fits, and using solver we got our theta and tau and k and m. So that's it for the Excel part, and now we will go to the tuning part after we got the transfer function, the GP, and we will try to tune it using PID controller. So this is our calculation for all the methods we have taken in the class. So this is our tau c. We assumed it to be 5, which is between the theta and tau. And here, as you can see, all the calculation for the methods like IMC and CC and ZN and all the other methods. And if we go now to the simulating part, we should see here we have indicated which one is which by indicating the color. So the IMC will be yellow, and the ITAE for the set point will be purple, and the ITAE for the disturbance will be light blue, and then the last one, the CC, will be green. So we'll go ahead and run that, and here we should get our results. So this is our result, and as you can see that the purple color, which is the set point of ITAE, seems to be the best out of them all, and the second best is also ITAE but the disturbance. So this is the blue color. And that's it for our tuning part. Okay, this is part B of the extra credit marks, and we are building our own PID. So basically the idea is to convert our Arduino into PID, and the way we do that is by coding it to behave like a PID. So this is the code we wrote. As you can see here, we are calling the library of PID. So basically our Arduino will behave like a PID, and then we are controlling the valve by using a servo motor. So basically servo motor acts by manipulating the angle of it, and then PID controller needs KP, KI, KD. So there is where we include it, and we will try all the methods we have learned and see which one is more stable or make our system more stable. So basically the PID, it needs an input signal, and here where we get our input signal, so basically it is from the ultrasonic sensor, and then the output signal is from our servo motor. So we will just make the servo rotate to adjust our set point. So here we are telling it that the set point is 10 centimeters. So basically 10 centimeters from the ultrasonic sensor to the water surface. And here we can see that just now we are at the steady state. so it is actually moving and at the steady state. So this is how it should look like. So as you can see here, it is at 10 centimeters, and that is our set point that we initialized in here. Just now the servo motor is not rotating because it is at 10 centimeters, which is the set point. So can you hold it? Okay, so this is how we will close the gate and open it. Okay, so basically when I move the object near to the Arduino, it means that the tank is overflowing, which will cause the gate to close. And then when I move the object far from the ultrasonic sensor, it means that the tank is getting empty. So basically that will make our valve open. So we will go ahead now and change both of them and see how it changes. So if we go here to the monitor, we will see that it will keep changing until it sets back to the set point. So this is the idea of the PID controller we are using, and we will try to apply it to the real system now. Okay, so now we completed the final model, or at least how it will look like, and this is how it looks like. So basically this is the Arduino, and which is our PID controller, and then this is the servo motor, this is the inlet. You can see our system there. So the pipe is going from down. So this is our inlet, and whenever it overflows or it starts to increase, the PID will send a signal for the servo to turn off the flow rate. Then so basically it will look something like that, turning off and on until it reaches to the steady state back. And the reason we did that and not control the valve is because the valve is too hard for the servo to rotate. Basically we would have to drill in the wall, so we didn't want to do that, and instead we just focus on the inlet. And basically it is the same idea of controlling the valve, but we are controlling the inlet. So as you can see now, the PID is trying to increase the flow rate. So you will see the amount it is letting go is more than the previous one. So basically it is letting the flow rate go inside until it reaches to the set point. Okay, we set the set point to 16 to see to actually monitor it on the screen, and as you can see here, most of the results are on the 16 bar, which means that the PID controller is doing a good job in preventing the increment of the flow rate. So that's why it is a bit lower than 16, because we increased the flow rate, but so that it actually wants to decrease than 16, but the PID is keeping it from decreasing. So most of the results, as you can see, is about 16, which is our set point, and the difference is due to two errors. The first one is from the ultrasonic sensor. Basically the surface of the water is moving a lot. And the second thing is because of the PID controller. It is not the high quality PID controller, but however it is keeping it at the steady state, which is 16, even though we increased the flow rate. So this is the end of our project, and the time we have spent, you will see it somewhere in here. Yeah, and it was a really hard work, but so much fun. and it was so much fun to work with my group. So yeah, thank you to Ihui and Fu and Izzati,
Thank you Salah.
and hope to work with you in a next project.